Find the LCM of a given set of counting numbers. So we have the numbers 7, 14, and 4. Okay, and so the first thing I'd tell you to do, this is my strategy for solving this, is that you want to know what these numbers, if they're prime numbers or what numbers they split into. And I'm going to give you a little chart right here that we can look at. This chart is just the prime factorization from 1 to 100. So you can look at this thing, and all the numbers in red are prime numbers, but they represent every number. So this is 1, 2, you can see 3. This is the number 4, 5, this is the number 6, and so on. So it keeps on going on. Remember, we're looking for 7. That's a prime number. We're looking for 14. 14 is made up of splitting that, because 2 times 7 equals 14. And then there was 4. That means that it's 2 times 2. That just means that this means how many of those numbers in the base. So it's 2 2s, right? If we're looking at 8, there's 3 of those 2s. But yeah, that's what we're going to look at right now. You're welcome to take a picture of that, and I'll be sure to put this image in your content folder. That way you can just have it available to you. So we said that 7 splits into, it's a prime number, it's just 7. And we said that 14 splits into 2 and 7, and 4 splits into 2 and 2. Now when we're thinking about the word least common multiple, we're thinking about making them have multiples or factors all in common. Now this has a 7, and this has a 7, right? But the extra thing on here is a 2. So this thing needs an extra 2. And now these things are in common, right? This has 2 2s, and these only had 1, so they need extra 2s to be just like this 4. And this 2, I mean the 4 is missing, it has the 2s, but it's missing the 7, so that's what this one needs. Right? And now they all have the same trio of numbers in their thing. And if you do the math to figure out what this is, and did 2 times 2, that's 4 times 7, that is 28. So the least common multiple for this is 28. Now we got the numbers 10 and 14. If we split these up, we get 2 and 5, and this one is 2 and 7. This one has a 5, this one has a 7, so they need what each other have. And now they have the same trio of numbers. If we multiply it all together, 2 times 5 is 10, times 7 is 70. All right, now we have 4, 8, and 18. This splits into 2 times 2. If we're doing 8, it's 4 times 2, and then this splits into 2 and 2. And since we split the 4, we're not going to use that anymore. We'll cross that out. If we're doing 18, it's a 2 and a 9, and this splits into 3 and 3. And we split that up, so we're not using that 9. So if we're looking at this, let's split this into categories. That way you can see it. This has 2 2s, and this has 3 of them, right? So this needs an extra one. Right? And now these 2 are in common. This only has 1 2, and these had 3 of them, so this needs an extra pair of 2s. Right? And then this needed those trio of 3s. So we got a 3 and a 3 here. And so this one needs both of those. Okay, and now if we multiply this all together, this is already 18 times 2 is 36, and then 36 times 2 is 72. All right, so this is step 2 of this. It says determine the number of times each number divides into the LCM. Okay, so remember in the first step we had 72. Basically what we did is this is the 4. So if we take 72 and we divide it by 4, basically what we're going to get is what we found to be right here. If you think about it in terms of fact families that you learned back in school, that you can multiply this times this and get that, or you can go in reverse. So 72 divided by 4 equals this number. Now 2 times 3 is 6, times 3 more is 18. So that's our answer for 4. 72 divided by 8 is 3 times 3, which is 9. And then 72 divided by 18 is this, 2 times 2, which is 4. So those are your answers for your step 2. Let's do these. So we got 18, which splits into 9 and 2. And this splits into 3 and 3. We got 20, which splits into 5 and 4, and 2 and 2. You could have gone 2 and 10 and then split it's been 2 and 5, but you'll notice that you get the same numbers on each one of these, no matter what you do, no matter what direction you go in. 9 is going to be 3 and 3, and then 4 is going to be 2 times 2. Okay, so now we're giving them what they don't have, right? So this has, and these are real different, right? So they have a 2 in common, but this one needs an extra 2. It also needs the 5, right? This one needs the 3's. And this one has the 3's, but it needs the 2's and the 5's. So it needs 2 2's and a 5. This one has the 2 2's, but it needs the 3's and the 5's. So we get 3 times 5 for this one. And so they have the same 5 sets of numbers in each one of these. Okay, so if we multiply these together, this one's kind of the one I want to go with. This one's already 20 right here, and 3 times 3 is 9, and 20 times 9 gives us an LCM of 180. So once again, we're looking to see what these numbers divide into, and what we added on the bottom is going to give us our answer. So 180 divided by 18 is 10. 180 divided by 20 is 9. 180 divided by 9 is 2 times 2 is 4, times another 5 is 20. And 180 divided by 4, 3 times 3 is 9, 9 times 5 is 45. A fruit production company has 3 packaging facilities, each of which uses different size boxes as follows: 20-piece boxes, 28-piece boxes, and 16-piece boxes. Assuming that the truck provides the same quantity of uniformly sized pieces of fruit into all 3 packaging facilities, what is the minimum number of pieces of fruit that will be delivered so that no fruit will be left over? Okay, so basically they're putting the same number of fruit in each one. So basically this means that we're looking for a greatest common factor. So we're doing the same thing we've been doing. So we're splitting up 20. That's 5 and 4, and then 2 and 2. This is going to be 4 and 7. We got another 2 and 2. And then 16 is 4 times 4, and then the 4 split is into 2 and 2 and 2 and 2. Okay. So each one of these needs the 5. Oh, sorry. This needs the 7, and this needs the 5, right? These have an extra set of 2's that they bring in, so these need a pair of 2's. And this needs both the 5 and the 7. And so we should have 6 total numbers in each one of these, and that's what we have. So we're going to have to multiply this together. We got 28, and then times another 2 is 56, and then 5 times 2 is 10. So this is going to be 560 is what this totals out to be. So now it says, assuming each facility will receive the same amount of fruit, how many boxes will each facility package? And that's the same thing as what we're doing here. We're actually taking this and dividing it by this to get this answer. So these are our answers for our step 2. So 560 divided by 20 is 7 times 2, which is 14, times another 2 is 28. 560 divided by 28 is this. 5 times 2 is 10, times another 2 is 20. And then 560 divided by 16 is 35. So that's our answer for each one of these. Raise the following fraction to higher terms as indicated. We have 3 over 5, and that's equal to something over 85. So we're just trying to figure out what this numerator is going to be to make an equivalent fraction. So what we do to solve this is we ask ourselves, what did we multiply to get here? Okay, and if we're going in reverse, so we're starting with the big number and trying to go backwards, we can just take 85 and divide it by 5 and figure out what that is. So our answer is 17. Now, whatever we multiplied the bottom by to get to here, that's what we're going to have to multiply our top by. So we're going to multiply that by the same 17. And so if we do 3 times 17, we can just do times 3. That gives us 51. So that's our numerator that we're looking for. Doing the same thing on this one, we're thinking, what did we multiply 5 by to get to 55? Somebody might go, oh, that's easy, that's 11. So that's what we're going to do our numerator by. So 6 times 11 is 60. 4 tour buses depart the terminal on the same day. The itinerary of the first bus takes 4 days. For the second bus, it takes 6 days. For the third bus, it takes 12 days. And for the fourth bus, it takes 21 days. Assuming that another tour begins the same day that the bus returns to the terminal, how many days will it take until all 4 buses return to the terminal on the same day? Okay, and we can figure this out by doing the same thing we've been doing because we're just multiplying. So that first bus, it's 4 times 1, it comes back in 4 days. 4 times 2 is going to come back in 8 days. And so we want to see where, if we keep multiplying these things, which is where least common multiple comes from, where how many days it'll be before they're all back at the terminal at the same time. I wrote these out of order, but it's going to be just fine. But we're going to do this same way. So 4 is made up of 2 times 2, and then 12 is made up of 4 times 3, and that's 2 and 2. 21 is made up of 3 and 7, and 6 is made up of 2 and 3. So we want to make these all alike. Have the same groups in here. It says 2 2's, and that one has an extra 3, so let's give this one a 3. This one has a 7 that this one needs. And I think we're good there. So on this one's missing the 7. This one's missing the 2 2's. And then this one is missing an extra 2, and a 7. And so we have the same 4 numbers on each one of these. Okay. And so if we're doing the math on this, this is going to be 21 times 4, which is 84. So all these buses should be back in 84 days on the same.